Hi guys, this is Saurav here and welcome to this JEE Advanced Aspire session for the JEE Advanced Examination 2019. We had conducted similar sessions for JEE Mains in the month of December, and this is primarily aimed at the advanced examination, the kids who are preparing for the advanced examination. Now, the whole array sequence of topics is very vast, very elaborate, and we have divided each topic into certain subsections depending on the difficulty level of the topic and the parts that we need to cover. So it is pretty comprehensive. So agar aapko advanced mein excel karna hai, then my request would be to just focus on the basics, solve the questions simultaneously with me, and review your mistakes. Okay, ये तीनों चीजें आपको करनी है. Now, my topic today would be of liquid solutions 1. Now, liquid solutions 1 would cover ideal solutions. Liquid solution 2 would be the next session in which we would be covering non-ideal solutions. So before proceeding ahead, I'll give you a very quick introduction of mine to students who do not know me and who have seen me earlier in December और मेरे को भूल चुके हैं. I'm Saurav Goswami and I am from NIT Rourkela. I've been teaching for IIT JEE for about 10 years now, and sit back and enjoy the session. Please keep a pen and a paper handy so that you solve the questions simultaneously with me. So let's dig into the first question. Let's see what it is. So the first question is about phase diagram. First question is about phase diagram. For a given phase diagram, which of the following statements is or are correct? मैंने questions को specifically JEE Advanced के level में frame किया है because JEE Advanced में single option correct question तो आते हैं, वो तो mains में आपने cover कर लिया, लेकिन multi option correct question is also pretty challenging. Multi option correct question will give you very good returns, and number of questions multi option के कम रहते हैं. कभी अगर ज़्यादा भी हो गए तो भी आपको घबराना नहीं है. Okay, so in this sequence, in this segment, my objective would be to make you comfortable with the multi-option correct question. So please look at the question. The question is about phase diagram, and what do we have to infer in this? We have to infer that the two phase diagrams, that is curve 1 and curve 2, are for two different substances जिनमें हमें आइडेंटिफाई करना है कि what is the relation between the density in the solid phase and density in the liquid phase. First and foremost, I need to know what is a phase diagram. Okay, so the phase diagram represents the existence, or it's a graphical representation of the existence of three different phases of a matter, that is solid, liquid and vapor, at given condition of pressure and temperature. Okay, so let's try to solve this question. So इस क्वेश्चन को सॉल्व करने के लिए मैं आपको पहले एक छोटा सा बेसिक्स आइडिया दे देता हूं. दिस इज प्रेशर एंड दिस इज टेम्परेचर. एक फेज डायग्राम में हम लोग तीनों फेज डिस्प्ले कराते हैं, सॉलिड, लिक्विड एज वेल एज गैस, एंड दिस वुड लुक समथिंग लाइक दिस. ओके, आइडियली और इनवेरिएबली हम लोग अगर एक सिंगल कंपोनेंट की बात करें, अगर वाटर की बात करें, देन this region will represent the solid phase, this will represent the liquid phase, और ये vapor phase है. Okay, solid, liquid, vapor. The dark lines, ये जो lines हैं, these lines represent the pressure and temperature condition at which solid is in equilibrium with liquid, or solid is in equilibrium with vapor, or liquid is in equilibrium with vapor. That means these solid lines represent the pressure and temperature conditions at which any two phases are in equilibrium with each other. That means if I take this point, then this temperature and this pressure condition represent when solid would be in equilibrium with liquid. Now हमारे पास एक पहले का आइडिया है कि solid and liquid are in equilibrium at melting point, and that's not always the reason. I can modulate the temperature and pressure, and वो equilibrium को मैं shift कर सकता हूँ. Okay, so This is the basic idea. How do we incorporate this idea in our question? So let's look at the question once again. So हमारा क्वेश्चन इस तरह का है, हमको डेंसिटी आइडेंटिफाई करनी है. नाउ दिस क्वेश्चन कैन बी सॉल्व वेरी इजीली. व्हाट आई विल डू इज I will take a temperature condition. I will take a temperature condition against which I will try to identify a pressure condition. ये टेम्परेचर हमने ले लिया T. इस टेम्परेचर पे हमारा सॉलिड लिक्विड के साथ इक्विलिब्रियम में है. फाइन. उस पे एक प्रेशर एग्जिस्ट कर रहा है. एंड नाउ व्हाट आई विल डू इज I will increase the pressure. I will increase the pressure keeping the temperature constant. So if I increase the pressure keeping the temperature constant, let's say the pressure becomes P dash. What do I observe? We started from a region where solid was in equilibrium with liquid, but now we have reached a region where we have only liquid phase. This region lies in the liquid phase. So this region lies in the liquid phase. That means if I take solid in equilibrium with liquid and I increase the pressure and I reach liquid, इसका मतलब equilibrium liquid की तरफ shift कर गया है. अगर ये equilibrium liquid की तरफ shift कर गया तो ली चैटली प्रिंसिपल लगाइए. अब try to incorporate Lee Chudley principle. If I apply pressure and the reaction moves in a certain direction, the reaction will always try to move in a direction where volume decreases. So while pressure is increasing, the reaction is moving in a direction where volume decreases. That means the liquid is having lower volume than the solid. Liquid has a lower volume than the solid. If liquid has a lower volume than the solid and mass is constant, mass क्यों constant रहेगा? आपने कुछ बर्फ लिया, उसको मेल्ट करा दिया, mass तो constant रहेगा, लेकिन volume change कर जा रहा है. So volume changes, mass remains constant, volume is less for the liquid phase. So what will be the relation for density? Density will be higher. डेंसिटी विल बी हायर. अगर डेंसिटी लिक्विड का ज्यादा है तो हमारे पास कौन सा ऑप्शन करेक्ट हो जा रहा है? लेट्स लुक एट द ऑप्शंस. कर्व 1 इज फॉर अ सब्सटेंस वेयर D solid is greater than D liquid. No, D solid is less than D liquid. So B is correct. B is correct. Let's apply the same concept for curve 2. I take the same method. Temperature constant. I keep the temperature constant and then I take a pressure condition. I increase the pressure. Where do I land up? Solid, क्योंकि ये solid region है, ये liquid है और ये vapor. So I increase the pressure. I land up in solid region, equilibrium gets disturbed and I move towards solid. That means the volume of solid is less. If volume of solid is less, the density of solid will be more. Because mass per unit volume is density, the density of solid would be more and our relation would be this. Okay, so actually ये C होना चाहिए. This should be C and this should be D. But so our relation would be B and D according to whatever I've written over here. B and D would be the right answers to this question. Now, never ever density of solid will be equal to density of liquid because mass will remain the same, but density will keep changing because solid might be a compact phase or might be a more voluminous phase. Like water में क्या होता है कि density of solid is more, density of solid is less. That's the reason ice floats on water. And because volume of ice is more. Okay, so this is the first question. Let's move on to the next question. So the next question is, let's read the next question. The depression and freezing point of 0.01 molal solution of aqueous acetic acid is 0.02046. Assuming that the molality is equal to molarity, which of the following statement is or are true? हमारे पास दिया गया है क्या निकालने को? degree of dissociation, pH and pH. So they have combined colligative properties with ionic equilibrium. Colligative properties has been combined with ionic equilibrium. Let's try to solve this question. बहुत easy question है, solve करने का तरीका बहुत simple है. हमें ये मालूम है कि we know this fact that the depression in freezing point delta TF is equal to I, which is the Van't-Hoff factor, times Kf, which is the molar depression or cryoscopic constant, times molality. This is known to everybody. Okay? This is known to everybody. So it's given that depression freezing point is given as 0.02046. Kf will be I. Kf का वैल्यू कितना दिया गया है 1.86 and molality is given as 0.01 molar. Okay, if I solve this, I will come as I'll divide it by 0.01. This will become 2.046. 2.046 by 1.86 would be nearly equal to 1.1. हम बोल सकते हैं 1.1 के बराबर हो जाएगा. ये 1.1 के बराबर है. Now I write a next equation. CH3COH will dissociate to form H plus and CH3CO minus. I can write this very simply. I can write this. Now I take 1 mole of this. This will be 0, this will be 0. अगर ये 1 minus alpha लिखते हैं हम तो ये alpha हो जाएगा, ये भी alpha हो जाएगा. It's known to everybody. ये 1 minus alpha, this is alpha and alpha. What is Van't-Hoff factor? Van't-Hoff factor is the amount of substance which is present after a certain time divided by the amount of substance which was taken initially. तो total amount of substance which is present after a certain time, मतलब equilibrium पे कितना present है? 1 minus alpha plus alpha plus alpha. So this is equal to 1 plus alpha. Initially was 1. So Van't-Hoff factor I will be equal to 1 plus alpha. Okay. So 1 plus alpha, I का value 1.1 था. 1 plus alpha. So alpha की value क्या हो जा रही है? Alpha turns out to be equal to 0.1. Alpha is equal to 0.1. Okay. Very simple. Alpha is equal to 0.1. तो हमारा initially B correct हो गया. अगर B correct होता है, देखते हैं second equation क्या, pH निकालना है. So what is pH? H plus ion concentration. Now this is for 1 mole. This is for 1 mole. अगर हमने ये X moles के लिए किया, if I do it for 1 mole dissociates to an extent alpha, N moles will dissociate to the extent N alpha. So if I multiply this with concentration, I will get something like this. So that means the H plus ion concentration, will be equal to C alpha. C value is 0.01. Molal is equal to molar. Molality is equal to molarity if it is given in the question. That means 0.1 times what is the value of alpha? 0.1, which is equal to 10 raised to minus 3. This is the H plus ion concentration. And what is pH? Negative log of this. So pH turns out to be minus log of 10 raised to minus 3, which is 3. So our answer should be B and C. Now, how difficult was this question? This question was not difficult. However, you can waste a lot of time identifying in which direction should you be proceeding. Okay, so you had to be a little thorough with ionic, a little bit of mole concept, a little bit of colligative property. 3 सब टॉपिक्स को मिला के एक क्वेश्चन बन रहा है. इस 3 तरह के क्वेश्चन आपके जेईई एडवांस्ड में आएंगे, मिक्स कंसेप्ट के क्वेश्चन. ओके, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. Next question. What is the number of molecules of an organic compound undergoing polymerization if 9.4 gram of an organic compound is present in 100 gram of solvent and 100% polymerization occurs. Polymerization is a process of association. Polymerization is a process of association. Amount of substance decrease करता है. So what will happen? Assume that the depression is 0.93 Kelvin. So what would happen in this situation? कैसे solve करना है क्वेश्चन को? अगेन ये क्वेश्चन एक इंटीजर टाइप क्वेश्चन है. देख लीजिए क्वेश्चन का लेंथ कितना ज्यादा है, कोई ऑप्शंस नहीं दिए गए हैं, मतलब एक इंटीजर टाइप क्वेश्चन है. ओके ये इंटीजर टाइप क्वेश्चन है तो इसमें आंसर 0 से 9 तक हो सकता है, या फिर जेई का नया जो पैटर्न है उसमें यू कैन हैव डेसिमल प्लेसेस. सो बी वेरी वेरी केयरफुल विद द कैलकुलेशंस. नाउ यू कैन सी दैट द नंबर्स आर वेरी सिमिलर टू ईच अदर. 0.93 है, 1.86 दे ऑलमोस्ट ट्वाइस है. 9.4 and 94. So don't get worried about the numbers. पहले इक्वेशन लिख लीजिए फिर नंबर्स लिखिएगा. So हमारा इक्वेशन क्या होना चाहिए? Our equation should be delta TF should be equal to I times KF times molality. Delta TF depression, Venter factor, cryoscopic constant times molality. Delta TF कितना दिया गया है? 0.93. ये I के बराबर हो गया. KF is 1.86. ना मोलैलिटी आपको कैलकुलेट करना है. मोलैलिटी इज वेट ऑफ सब्सटेंस, सॉरी मोल्स ऑफ सब्सटेंस इन 1 kg ऑफ सॉल्वेंट और पर kg ऑफ सॉल्वेंट, पर kg ऑफ सॉल्वेंट. सो मोलैलिटी निकालने के लिए आपको पहले नंबर ऑफ मोल्स निकालने. सो 9.4 by 94, 9.4 by 94 that is 0.1 moles. So 0.1 हम यहां लिख देते हैं. 100 ग्राम ऑफ सॉल्वेंट, 100 ग्राम सॉल्वेंट का मतलब 0.1 kg. Okay, so this gets cancelled out. I becomes equal to 0.93 by 1.86. कितना हो गया ये? 0.5. I is 0.5. Now the interesting part is this is association. Okay, this is association. So association is form में होता है. Okay, I'll write it over here. Association will take place in this form. A changes to AN. 1 0 1 minus beta, and this is beta by n. Okay, this is beta by n. डिग्री ऑफ एसोसिएशन को मैंने बीटा करके रिप्रेजेंट किया है बिकॉज डिग्री ऑफ डिसोसिएशन ऑफ अल्फा, थोड़ा सा डिफरेंस लाने के लिए मैंने इसको बीटा लिख दिया. नाउ यहां पे क्या लिखा? 100% पॉलीमराइजेशन. सो बीटा का वैल्यू 1 है. बीटा रिप्रेजेंट्स डिग्री एंड डिग्री विल बी 1 इफ एक्सटेंट इज 100%. तो अगर हम बीटा को 1 लिखते हैं देन दिस विल बिकम 0 एंड दिस विल बिकम 1 by n. ओके, व्हाट इज वेंट ऑफ फैक्टर? Total amount of substance present at a given point divided by the original amount. Total amount of substance कितना? 1 by n divided by the original amount, that is 1. So Van't Hoff factor I is equal to 1 by n. 1 by n is equal to 0.5. So what should be the value of 2? What should be the value of n? Sorry, value of n should be equal to 2. मैंने पहले ही आंसर बता दिया, sorry. So value of n should be equal to 2. इसका मतलब कि it is undergoing what type of polymerization? It is undergoing dimerization. So आपको ऑप्शन में ये भी लिखा जा सकता है कि it is undergoing dimerization, tetramerization, trimerization, pentamerization, and the value of beta can also be written, or you could be given the value of I. I is 0.5, I is 0.6, 0.7. ये एक मल्टी ऑप्शन करेक्ट क्वेश्चन के फॉर्म में भी फ्रेम कर दिया जा सकता है. ओके, very easy question. Let's move on to the next one. So guys, let's look at this problem. Which of the following statements is or are correct for ideal binary solution of two volatile liquids? Binary means 2, tertiary means 3. Binary is also known as a two component system. Ideal solution वो होते हैं जो कि Raoult's law को follow करेंगे. Okay? Now, an example of an ideal solution will be CCl4 and carbon disulfide, benzene and toluene, hexane and heptane. क्यों हम इनको आइडियल बोल देते हैं? बिकॉज इनके प्रॉपर्टीज ऑलमोस्ट अलाइक हैं. ओके, दे आर नॉन पोलर सॉल्वेंट्स एंड they do not interact to a very large extent with each other except for any degree of some dispersion forces. Okay, they do not have hydrogen bonding और इस तरह के कोई interactions नहीं रहती हैं. So the properties are almost like, so alkanes, aromatic hydrocarbons, a mixture of them will turn out to be an ideal solution. Let's look at the question. Question क्या कहता है? The vapor is always richer in the more volatile component. The liquid will gradually become richer in the less volatile component. Total pressure above the liquid is equal to the sum of vapor pressure, and boiling point of the solution will be less than the boiling point of the two components. Now, to understand this question, I can tell you the theory or I can explain you the plots. Okay, so plots समझ लीजिए because plots are pretty important. So, plots समझने के लिए हमें करना क्या होगा? That we will try to identify that what does the vapor pressure versus composition plot looks like, and what does the boiling point versus composition plot looks like. If I understand these two plots, I can solve the question very easily, and many other questions like this. So, vapor pressure versus composition plot will be drawn like this. I will take a plot like this. This is vapor pressure of two liquids which have been mixed together. This is the axis on which I'll plot the vapor pressure, and this composition. The composition has been taken in terms of mole fraction. So ये मोल फ्रैक्शन A हो गया, A का 1, और यहाँ पे मोल फ्रैक्शन ले लेते हैं B का 1. I am taking pure A and pure B. If 1 लिया गया, that means pure solvents लिए गए हैं. Okay, if 1 is taken, then it is pure solvent, and I've taken a mixture of two liquids, A and B. Okay, assume that vapor pressure of B is higher. B is more volatile. More volatile होगा तो vapor pressure higher हो जाएगा. तो वेपर प्रेशर हाई हो गया बी का. सो दिस इज पी नॉट बी एंड दिस इज पी नॉट ए. ओके, ऑल्सो यू नो दैट pressure at any point, partial pressure due to any liquid is mole fraction of that liquid times the ideal vapor pressure. The ideal vapor pressure is that of a pure component. So that means if the mole fraction keeps on decreasing, linear decrease हो रहा है, 1 से लेके 0 तक जा रहा है, linear decrease हो रहा है, तो ये भी linearly decrease करेगा. So linear decrease हम किस तरह से दिखाएंगे? Like this. And a linear increase will be shown like this. Okay, linear increase will be shown like this. What will be the vapor pressure at any intermediate point? Like this. So at any intermediate point, let's say at this point where mole fraction of A is some value, mole fraction of B is some value, at this point the vapor pressure will be given as P is equal to mole fraction of A times P naught A plus mole fraction of B times P naught B. So अगर आपको याद होगा तो हमारा थर्ड स्टेटमेंट इस कारण से गलत हो जाता है, क्योंकि थर्ड स्टेटमेंट में ये लिखा है कि इट इज इक्वल टू द सम ऑफ द वेपर प्रेशर, बट नो, इट्स नॉट इक्वल टू द सम ऑफ वेपर प्रेशर. इट इज इक्वल टू द सम, it is equal to the mole fraction times the ideal vapor pressure plus mole fraction times the ideal vapor pressure. It's not equal to the sum of ideal vapor pressures. Okay, now if I want to draw the boiling point versus composition plot, it is again very simple. You have to just remember that if vapor pressure is more, boiling point will be less. इसका रीजन क्या है? मान लीजिए कि अगर आपने वाटर लिया और एसीटोन लिया, एसीटोन तो हमारे हाथ में रखने से ही इवेपोरेट कर जाता है, तो एसीटोन ज्यादा वोलेटाइल हो गया. ज्यादा वोलेटाइल होने का मतलब कि इट्स टेंडेंसी टू एस्केप इनटू द वेपर स्टेट इज हायर, and if its tendency to escape into the vapor state is higher, its vapor pressure is also higher. So vapor pressure उसका higher था तो उसका boiling point क्या था? कम. If vapor pressure is low, boiling point will be higher. Okay, so vapor pressure decreases, boiling point increases. So I draw it in this fashion. This is again composition of A is 1, composition of B is 1. इंटरमीडिएट में कुछ होगा, मिक्स कर दिया आपने, मोल फ्रैक्शन ऑफ B can be some value, A can be some value, but at these extremes we are taking pure solvents. So pure solvent अगर हम A का लेते हैं और A का boiling point अगर हम आइडेंटिफाई करना चाहते हैं, then I compare it with the partial, or I compare it with the ideal pressure of P. P का pressure or vapor pressure is less than compared to the pressure due to, or ideal pressure due to B. Then sorry, A is less as compared to B, so boiling point of A will be more than boiling point of B. In an ideal solution, the plot will look like this. For an ideal solution, it will look like this. Okay, it will look like an eye, एक लीफ के जैसा आपको दिखेगा. Okay, it will look like that of a leaf. This represents the liquid curve. This represents the vapor curve. इसका रीजन कहां से आता है हमें उसको जानना नहीं है. There is an equation for that, but we'll have a plot like this. Okay. Now, इस प्लॉट में जो हाईएस्ट बॉइलिंग पॉइंट हो रहा है, that is for liquid A. Lowest boiling point is for liquid B, and all other boiling point values are obtained at different composition. That means अगर मैं इस पॉइंट पे अगर boiling point निकालना चाहूं तो मैं क्या बोलूंगा? boiling point क्या है? I will get a boiling point value which is this. Okay, अगर मैं इस पॉइंट पे निकालना चाहूं तो boiling point हमारा ये हो जाएगा. So अब किसी भी पॉइंट को ले लो, the lowest value is that of the less boiling liquid, or the liquid with a lesser boiling point, or the one which is having which has a higher vapor pressure, and B and A के बीच में ही रहेगा. Okay, B and A के बीच में ही रहेगा. Okay, so how do we solve the previous question? The question can be solved like this. Vapor is always richer than in the more volatile component. It's always true. जो ज्यादा volatile होगा पहले escape करेगा. Correct. अगर वो पहले escape कर गया, the one which is more volatile escapes out first. Then what will be left as the residue? The one which is less volatile. So liquid will gradually become richer. So vapor, look at these terms. Vapor is richer in more volatile component. Obviously, the liquid will gradually become richer in the less volatile component, because the more volatile component goes off as the vapor. So this is also correct. Total pressure of the solution is equal to sum of vapor pressure of the two pure components. No. It is equal to mole fraction times pure component. Okay. It is incorrect. This statement is incorrect. Last statement, boiling point of the solution will be less than the boiling point of two components. No, solution, that means at a point where there is some A, some B, will always lie between boiling point of pure A and boiling point of pure B. Okay, it will never be less than that. B का सबसे कम होना चाहिए और A का सबसे ज्यादा होना चाहिए. ओके, सो फॉर एग्जाम्पल इसका एक बहुत सिंपल चीज आप याद रखो. अगर A का बॉइलिंग पॉइंट 50 डिग्रीज है एंड B का बॉइलिंग पॉइंट 70 डिग्रीज है, देन A प्लस B का जो वैल्यू होगा वो मोर देन A होगा एंड लेस देन B होगा इफ इट इज आइडियल. इफ इट इज आइडियल, द बॉइलिंग पॉइंट ऑफ द मिक्सचर विल बी लेस देन दैट ऑफ B and more than that of A if it is ideal. But if it is non-ideal, then A plus B will be even smaller than A, or A plus B can be even greater than that of B. Okay, if it is non-ideal, then A plus B का जो boiling point होगा वो A से भी कम रहेगा, or it can happen that it is more than that of B. Either of the two cases, that is the reason we call it positive deviation, negative deviation, and this we'll read in the next session. Okay, so with this we finish all the questions designated for today's session, but I will end the session with a important message. Okay, and the message is this, that pain is temporary, but quitting remains or lasts forever. Lance Armstrong, a 5 times Tour de France winner, suggested that, और ये बहुत ही important है जानना आपके लिए, क्योंकि आप बहुत मेहनत कर रहे हैं. Like you are working hard for past 2 years. Right now your body is slogging up. You are leaving all comforts. You are missing movies. You are missing all the party. You are missing every family outing just so that you focus on the final goal. And this is painful. Body goes through a lot, your mind goes through a lot. You have to keep yourself motivated for the final goal. And this, though being painful, the path being full of struggle, but the end is beautiful. But if you quit because एक question मेरे से नहीं हो पाया, I couldn't perform as good as I should had in mains, then you will always regret the fact that, man, like if I'd have put some more effort, I'd had been a little diligent, थोड़ा सा हो जाता, शायद हो जाता. वो शायद का जो हिसाब है, that point or that hunch that I might do that, I would have done good, will always be with you if you quit right now. So if you find something getting difficult, put more effort. Don't quit. Believe in yourself and don't quit. So with this message, this is Saurav Goswami signing off, and we'll meet in the next session with another interesting lecture on liquid solutions, which will cover the non-ideal solutions part. Thank you. Bye-bye.